team. Today I thought I'll just quickly do a video of what we're doing for this week, where we're starting. Remember, we've done the ions and how ions form and atoms and all that stuff and writing formulas. So from now on, we're going to learn about the actual like acids and bases, what makes an acid, what makes a base, and how do they react with different things and with each other. So like I said, we've done this last year, but some of you might have been in lockdown, and so you might have missed something. So we'll just go from the start, and then from there we'll move on to the level 1 work. So today we're just going to talk about what is an acid and what is a base and what makes them special. And then when we look at our chemical formulas, how can we distinguish between an acid and a base? Okay, so if we have look at an acid, some examples of acids are vinegar, lemons, oranges, citric acid, all those things, and all of them share some common features. So when you think of all those things, you would kind of think that they're all sour. And if you get like a lemon in a cut or something on your hand, it burns, or it's a tingly feeling on your skin. So that is kind of what the properties of an acid is, that they taste sour, they feel tingly and burning on your skin. So when we look at a base is pretty much the opposite. So examples of bases are soap, dishwashing liquid, baking soda, all those things that have like a bitter taste to it. So the yucky feeling in your throat when you eat it. I don't know if you've ever tasted soap, but yeah, if you swear you kind of take a bite out of the soap. So all of that has a little yucky feeling in your mouth and in the back of your throat, that bitter feeling. So all bases are bitter, and when you feel that, they're all like soapy, so they're all smooth and silky and just quite nice and when you touch it. So those are the differences between an acid. So when we look at acids, and I need you to write that in your book as well, taste sour and feel tingly. And then for a bases taste bitter and feel slimy or smooth, slippery. Okay, so that is the common properties of an acid and a base. So because we're at level 1 and we're not going to just look at what the properties are, what they taste like and what they feel like, we're going to actually delve into the chemical formulas. So when we look at chemical formulas, some acids formulas, we have HCl, that is hydrochloric acid. We have H2SO4, that's sulfuric acid. HNO3, that's nitric acid, and CH3COOH, that's ethanoic acid. And ethanoic acid is a fancy name for vinegar. But when we look at all these in the lab, not just lemons and vinegar and stuff like that we get in the kitchen, when we look at these ones, they all have a similarity in all of them. And when we look at the chemical formulas, all of them have the H attached to them. So because they all have H's attached to them, that's how we chemically can identify that as acids. Because when I put them into water, what's going to happen is they're going to break up and release these hydrogen ions. And the hydrogen ions, remember, a hydrogen ion is a positively charged hydrogen atom because it's lost an electron. So these hydrogen atoms are floating around in the liquid, and that is what makes it taste sour, and it makes it feel stingy and tingly when we feel it. So that is how we identify acids. So acids are identified by their H ions they release in solution. Okay, so when we have anything that contains an H that loses that H when it's in a solution, we call it an acid. Similarly, when we look at our base, we're going to look at our bases. We have, for instance, sodium hydroxide. We have lithium hydroxide. We have magnesium hydroxide, calcium hydroxide, and the list goes on. But when we look at these ones, although they have H's as well, there's something else that's also similar to them. Not just the H's, but the OH groups that's attached to them. And they all releases OHs. So that ion is a negative ion. So this OH makes it a base when it's put into a solution. So bases release OH ions when in solution. Okay, so it's not just the bases. We'll learn about oxides as well, because if we have an oxygen as well in some of them, they also act as bases. But when we for today, we're just going to look at if it releases an OH in a solution, then we know they are classified as bases. So an acid feels tingly and burny. It tastes sour. Bases taste bitter and it feels slippery. But also when we look at chemical wise, hydroxides or the acids releases H's in solution and bases releases OHs in solution. Scientific